when I'm a student in the last 2 years, we conduct boot camp in Mumbai, Pune, Chennai, London, and Manchester. It is a very short and it has people who are attending Meetup for the first time. People who attended Meetup previously in DataGiri. People from Mumbai come and people are in the data science or in the software directly. So there is a chance to people that we better than their great speakers. See what they do in the field. Basically started back in 2016. The vision to build a community where people could share the best practices in the updated with friends in the data community. So we are planning to 10,000 members strong, and we recently launched a chapter with Uber in Bangalore, where we had around 60 users. So, getting on to the agenda of the day, we'll be having 2 45-minute speakers. We'll be having 2 45 minutes talk, and post will be a Q&A session and a network session after that. So, we have Arunabh and please.
Hi guys, my name is Arunabh. I'll be talking about recommendation systems and the focus problem. But before that, before actually we started being what the focus problem is, let's know about recommendation systems actually. So most of you guys use Netflix, Amazon, Prime Video, and a lot of Savan. So before actually getting to what recommendation systems and the problems associated with that are, let's actually take a recap and say why would you need recommendation systems in the first place. So when you go to the supermarket, right, you have a set agenda that today I'm going to buy groceries, today I'm going to buy something. So say the supermarket actually, you have gone to the supermarket say twice or thrice, Reliance Fresh, and you buy the same kind of groceries every day. Imagine the 4th time you go there, the supermarket has rearranged itself to present to you what actually you like to buy. How great would that be? You don't have to go and search for what you want. So for every guy who is walking in, the supermarket has rearranged itself every time to present to you the items in the most likely to buy. So you don't waste time. The supermarket already knows what your preferences and which likes are, and it's giving you the most likely items that you would like. That would be great. That's what Amazon is doing actually. Amazon is not a bigger motor store, so that's what it does. So that's one of the primary differences between online store and offline, because you don't have to search the supermarket and know everything that you want. Bringing that analogy same to say Netflix. Most people go to Netflix on Saturday and Sunday. All do that. We just want to say that let's watch a movie. You don't really have a movie in mind. Most of the time, you usually just watch something. So how does Netflix actually figure out that what is that you will be liking? Could be 1,000 other things, and if you start giving you bad recommendations, what's going to happen is you wouldn't like what you watched and you wouldn't go to Netflix either. And that's the risk Netflix can't take. For instance, Spotify is not in India. A music app, for instance, say Ghana. So when you sign into Ghana for the first time, you see it asks you a lot of questions, right? What are the kind of songs you like? Also, there's an option Facebook login. But usually, if you log in through email, you would see that it asks you what songs you like, what are genres, languages, Bengali, Hindi, English, all that. Those keep asking those questions. Now, there are actually a pro and a con to that. I'm a lazy guy. I don't like to answer those questions. I just want to start listening to this. There is an advantage because at the moment a new user is coming in, until I know what he's going to like, I'm not going to start. I can't just recommend the most popular items which are on the menu. Many people are liking Nirvana, but we know that's a disaster. So from that, sort of with wireless, like I said, Amazon, Netflix, iTunes, Spotify. Netflix, Amazon, I'll get to later. Spotify is a music streaming device very similar to Ghana and Wink. It's not even in India, it's US only presently. They are great because they give you curated playlists every day at the beginning of the day based on your listening behavior over the past week. So I'll get to how that works. Yeah. So fine. The supermarket creates system every time you walk in, and you are it feels great because it's personalized for you. But how does it help supermarket? Why would you still? Yeah, obviously because now the supermarket is creating a system every time you walk in, and there's a supermarket which is like one of the supermarkets at DMart. I still want to go to the personalized supermarket because you already know who I am. So that's the whole agenda. I mean, why is Netflix recommending new movies that you would like but you haven't watched yet? So that you spend more time on Netflix. You watch more and more movies up to your liking, or you discover things which existed but you don't know. That's the whole point. So for instance, on Amazon, the whole idea is when you start browsing cameras and starts recommending different sorts of cameras to you, you spend more and more time on the website, and that increases the engagement or the revenue stream with the website. That's the whole point of recommendation systems. To make money. To basically make the whole experience a personalized setup for you so that you don't have to search for what you want, the system already knows what you want. And you spend more and more time, you buy more things on Amazon, you watch more movies on Netflix, you listen to more music on Spotify or Ghana. That's the whole point. The second point being massive choice. I think this is actually a bigger problem because there are, I don't know, a few million movies on Netflix maybe. It's very difficult for me to, because there must be a lot of great movies. Just off the record, if you guys haven't watched Black Mirror on Netflix, you guys should check it out. So, artificial intelligence. So I didn't know that. They just recommended that to me, and I will move to it process. So I didn't know it existed. But why did it happen? Because Netflix recommended that. I loved that. Now after that, I started recommending a lot of other stuff. For instance, Altered Carbon is a new series coming up. So these guys, I spend more and more time on Netflix. So it's such a huge choice. It will be impossible for a single guy to actually go to all of them and figure out what I like, what I don't like. That's making my job easy. That's one of the recommendations. That I already covered. About that as well. Right. So before I actually get into what this is, I'm sure all of you guys have shopped on Amazon, so what are you going to ask who else? So when you shop on Amazon, you see this that users who bought this also bought this. Right. That is something we call association rule mining. So that 90% of the users who bought a camera have also bought a tripod. Not necessarily which tripod, it could be any tripod, but they have also bought a tripod. Or 90% of users who bought a phone also bought a charger or mobile case. That's association rule mining. That is not what we do with content or collaborative. What is content is? Content is this. So say I already know what camera I want to buy. I want to buy a DSLR camera by say Nikon. So I go to Amazon, I type in Nikon DSLR. Now, say I want it for the first time. The most logical way to take this forward would be that Amazon starts recommending me other Nikon cameras with the DSLRs. That is the most ideal way to do. That's content. Alright, he does not know what my preferences, what my dislikes are. I have not given it any data yet. He just knows my location and just a few age and address and all of that. But I just like Nikon DSLRs. It's not going to start. Could also start showing me Canon DSLRs because DSLR tag. Just not start showing Canon. Start showing me washing machines. So no one's showing Canon. That's content. What's collaborative? Collaborative is, say you guys want to watch a new movie. Who you say there's no internet now. Before the internet came, what do? You go ask your friends. Your friends are somebody who are very similar to you. They have similar tastes. You don't go ask a random guy to what should I watch. You ask your friends. Friends already know your likes and dislikes. That's content. Or your friends have very similar tastes to you. You like Altered Carbon, your friend also likes Altered Carbon. You have watched GOT, your friend does not know GOT. So you want to ask your friend to watch GOT. So he didn't know about the existence of GOT until you told him that there is also something called Game of Thrones. You have to watch that. Now there's one more guy who has watched all two and he also watched Suits. He won't come to you guys and say, you know what, watch Suits. You guys are similar to each other, you like the same sort of stuff. But you're discovering a new show with every new friend who's coming in. That's a simple example of visual. That's not it. The whole premise being that if two people like the same sort of stuff, they also dislike the same sort of stuff, and this one guy has watched something which the other guy does not know yet, and assuming that this guy is also going to like what he does. That's all it is. It's very simple. Right, how is recommending? Before I actually get to this, primary on, I don't know how many guys, I don't vote. After you watch a movie, how many guys actually go to the page for actually rating a movie? You don't, I don't. You just go to the next one. You don't go for a star, it's like amazing. So, that actually, technically, if I was the guy who coded that recognition of like, you guys should vote, the explicit rating it. But explicit ratings are already there. They're at least more rarer than implicit ratings. Now, what implicit ratings are? Implicit ratings are something like when you go to Flipkart and you add a item to your product to your basket or your cart, but don't buy that. How will you do this? No money, I don't want to buy that. Or you kept browsing through cameras, a lot of cameras, similar kind of cameras all over the place, but you didn't buy anything. But you had if I actually had a look at every screen, like Nikon, DSLR, then mirrorless, Nikon, keeps going, right? So, with this system data, I can safely assume that you are interested in cameras. Or, since you added that GoPro to your cart or you buy, I assume that you are interested in the thing. And you keep seeing this, right? When you add something to your cart and you don't buy that, click on another, they'll send you an email. Yeah, are you having difficulties with it? That's implicit. I know that you're interested in this product, and I would start recommending you similar items. It is just taking a place in an explicit rating product. Nobody is going to directly go up to that and give it a 5-star, you know what I can. How many people comment and how many people, unless you actually have a bad review about the product. Most of them I go to Amazon, I see the funny comments. Because most of the comments are really fun. So unless the product is really mind-blowing or it's just normal stuff like power bank, nobody is going to be on a power bank. But suppose you start looking for one power banks, I know you're interested in power banks. That's an implicit rating. It is not normal, it is not direct like an explicit rating where I'm actually giving a power bank of 4 or 5 stars. But I know that it's a power bank because your existing data suggests so. You have added it to the cart, but you have not bought it. Or you have lingered onto that power bank, you have actually gone to the questions, the reviews, all of it. I know all of it is there, right? That only work when cookies are off. If the cookies are off, it's the whole all is over. Yeah, what customers bought. So I haven't returned anything, but I bought this. I haven't returned that item. So yes, I like that. So next time you go on to Amazon or Flipkart, you want to start recommending other shoes too. I already have shoes, I don't want shoes. Yeah. Click on browse. Like I said, the whole point of user base is that if you like this, you love that. There are a lot of problems with this actually. I mean, Postcard as I actually did a white small Postcard. It's just an engine. It takes some time to warm up before the engine starts running at optimum speed. So, Postcard is basically the initial problems the recommendation engine has in classifying or recommending new users or new data to users or new users to data which is not completely on. It's a temporary problem, but it affects every new user or movie which is coming up on Netflix. For instance, for the users. So there is an amazing movie, right? For instance, Auto Car. Say this Auto Car. Now, if you hardcore play that boarding play, you say Auto Car, most people don't know, right? It's also because YouTube may use ads or Auto Car, the news is coming up and all of that. Say there's no ad, there's nothing. And Auto Car is a great series. How would I know, even though I like Black Mirror and all of those things, that this series for Auto Car, that is a problem because you have a great product. But since there are no users extracting the product yet, I will not start recommending this product to other users because the other products which are older have got user ratings implicit and explicit. But this product is brand new, it came in just today. How would I recommend it to the users? Because I wouldn't know what the reaction to this one would be, right? Because this is a black canvas, so I don't know if they like it or not like it. They may like it, if they don't like it, then well, you don't want to watch that scene, right? So, this is what the poster product is all about. It's only when somebody has interacted with Auto Car and then said, you know what, I have watched the entire series. Not just have to do a rating, you have actually finished the whole series, but just 3/4 of it. And okay, he likes it. Now we go to a user and see what his secret features are. What are the other people from his location watching? What are the other people of his age, of his similar characteristics, all of the features and data sets are watching, and then we recommend Auto Car to these guys. That's the product postcard. What is the user postcard? Same thing for users. It's you're a new user, you're now signed on to Amazon or Netflix before, what would I recommend to you? I don't know. What would I recommend to you? I don't know what the dislikes or likes are. The first time I come on this website, you could like 1,000 things. And Amazon does not ask you what your preferences are. Unlike Ghana or content streaming websites, Amazon does not ask you, we are here for shoes or here for electronics. You just create an email account and just start. That's how Amazon works. So what do I do? There are really a lot of ways you can solve this, but there's one thing I will really harp upon here, that there is no one solution which fits all. And this is something which I keep repeating, that data science or generally these kind of problems, it is usually a mix of a lot of solutions. There is not one solution which fits all, because the problem statement is different. For instance, say you post a problem for a couple of users. You have come to Amazon to buy, I don't know, buckets. You have been buying buckets for 6 months, I don't know, something weird. Say you have been buying buckets for the last 6 months. So next time you go to Amazon, you want to suggest buckets to you. But now I don't know, you want to buy mugs. Say you want to buy mugs, you want to buy mugs. You don't realize this is going to be a problem for Amazon. You want to buy mugs. But Amazon thinks you are a bucket. But today you buy mugs. This is a poster. Because you are not following what exactly. Most of your data is private buckets, this rating, that rating, this is all of that, user base and all of that. Suddenly you buy mugs. Why you buy mugs? So what mugs do I recommend to you? I can't just recommend any mugs, blue color. I have to recommend good mugs to you. That's a post start. Even for a returning user who has also signed it. So post start is not something which affects only people who are coming for the first time. It's only if you go to Amazon and start searching for something you have never searched before, that's a post start. So recommendation is basically open assumptions. The whole of recommendation, the whole of this idea is basically on, like I said, 3 friends, right? 2 of them have watched Game of Thrones, 1 has watched Suits. So I'm telling my friend, you know what guys, you should also watch Black Mirror. Why? Because he makes me do all this sci-fi. I am assuming that he is going to like this, based on his previous behavior, that he has liked something which is very similar to this. Or since both of us like the same sort of stuff. And I also like, I must say, this joke, Justin Bieber. He likes Justin Bieber, I must say, you know what, this is what I mean. Because I'm assuming that I'm going to give this a high rating. That's the whole premise of recommendation systems. You are trying to predict what rating that user could have given the new product which the user has not seen. That's the whole point. That's why you see Netflix and when we do it, you might also like Netflix is a great feature where you go to the website and you click on series, it shows a similarity match in green on top. You guys should check that out. Yeah, so say there are a bunch of products I know that this user might like. I can't recommend all of them to this case, right? Because he has liked X amount of products. Based on these, I'm taking a call that since he has liked these many products, he would also like these, because the users who like these products have actually liked this. That's user-based collaborative system, it's most basic. But I can't just recommend this to your items to him directly on the screen. How would I do it? I'm going to recommend him on a ranking order, where what the probability that he is going to rate out of these 300, 5, 4, 3, 2, 1. You okay, recommend him at all. 5, the highest rating ones, I recommend that. It's basically conditional probability is. The probability that this guy is going to rate this high rating, provided he has already watched this. Provided that these one happen, provided that he already has. I don't know whether the equation here is not necessary. But that's the whole premise. The whole recommendation engine is trying to predict what you would like, which would ensure that you stick on the site and not go to some other site. If a node doesn't like it, you go vice versa. Content based, yeah. So what? In that case, so what do you guys think? Do you think user based or content based works better? Obviously, content based, because user based. I'm taking assumptions since Umil and I we both like Game of Thrones, and I also like Suits. You might not like Suits. You might not like Suits. That's how I know. I'm assuming because we both are similar good friends. But I don't know what his preferences are. I don't know anything about the products themselves. I just know about the guys. Now I don't know the problem of doing content based. Content based actually would be a great solution. Problem content based is. So say somebody likes suits, right? Give me a show with similar suits. I don't know. Let's say House of Cards. Now, if I ask you, give me an objective measure of the similarity of these two shows, there is no answer. Because, for instance, La La Land is a arty movie. It's also a bit of drama. But if I ask you, can you give me an objective measure of how much drama and arty it is? That's a subjective thing. To each man his own. Somebody likes Angasarna. Somebody likes Diwali. Shocking because people do like Diwali. Right? But somebody does not like Diwali. So how do I, just because he likes Diwali, exactly he knows like Angasarna. So I can know the products themselves to actually recommend because he likes this kind of movies. So he will like something which is similar. But how do you like the similarity? You come with a problem. So you have this commercial arty, drama and comedy. Godfather. That's a great movie. La La Land, both arty and have Hangover, which is comedy and commercial. You have Sleeper, which was that. Say this week. I like La La Land. It makes sense to recommend for according to Amazon Prime Video or Jogi. It makes sense to recommend because this is content based. I tell you the problem with this. Somebody actually has to sit down and make these tuples of numbers. What's the ratings of this? Is it actually arty? Is it actually comedy? Is it actually commercial or not? And by how much? Because you just can't say, okay, I'm just going to do this movie here, this commercial by how much? Like, what if I was, say, here? And she was doing, say, Gunda, which was here. You recommend Gunda to me, but you will recommend Godfather because the distance is too high. So how will that be the distance? That's not possible. It's subjective. I don't know how many of you guys have heard this app called Pandora Radio. Pandora Radio is again not available in India. It's very similar at Spotify. So they have a project called the Music Genome Project, where they try to actually classify songs based on 450 characters, like genre. Because genre is a subjective term. So when I say objective, I would say beats per minute. You can verify beats per minute. Or for a movie, you can say that box office collections, or director, same director. That's an objective measure. But how popular is the movie? How comedic or how funny is the movie? I don't know that. It's funny to me, it's not funny to me. That is a subjective measure. So there's this project of the Music Genome Project where they took each song and ran it to about 450 of its parameters. How uplifting it is actually, electronic dance music with this progressive trance. Because the genres have very, very fuzzy lines. You could have a house music or even electronic dance music, or you could have, there are a lot of other stuff like metal, for instance, rock. What really classifies the new way of British metal, that kind of thing. Those 450 attributes, they actually got a great analyst to sit through each of those songs and give a score on each of those 450 attributes. Each song took half an hour, and they did the work for 20,000 songs. You imagine how much time that would have taken, how much money that would have taken. So why is, now you know why content based, even though it's one of the holy grails of solving the recommendation is because if the machine knows what your likes and dislikes are, it's never going to have it. The problem happens, it's not possible. There are millions of movies on Netflix. There are millions of songs on Spotify, and millions of songs. It is impossible for me to actually sit through all of them and put a subjective score. This is uplifting trance, or this is going to be heavy, this is a walk-up number, this is a gym number, this is a sad melancholy song, this is a breakup song. Who's going to do all that? You don't have time for it. New content is being generated every day. What's the simpler alternative? Simpler alternative is to find people who have liked one particular kind of songs. Recommend these songs to guys who listen to that. This just makes things simple. Yes, it has its cons because, like I said, you might like something I might not like that. But those things are really there. There's a different problem called ratio. But content based is great, but again, it's not the right way to focus all the time unless because once your content starts becoming exponentially large, it's very difficult for you to keep track of what's up. You can't have an algorithm for this. People know the new genres of music, people know the new movies every day. How are you supposed to train your algorithm to find out how much comedy? I can't say this is one type comedy and one type art. I mean, this is a very subjective measure to do. You can't say this is drama, but this is also funny. Yeah, that's to be possible. I don't find it funny. I find it tragic. That's the problem. Yeah, the goals. So now, well, actually, these are users, end users and EIs. There is a matrix table. That's not mean that the whole you will see a few of you guys doing. Alright. So, like I said, explicit ratings, right? Few guys have actually rated also the movie items. And the ones you see which are black are the ones which are now been rated. People have just not rated these items. This is missing data. There is a problem again with what's data scarcity. Collaborative is a huge problem. Because there is nobody is rating these items. It's a postcard, it's a new item. Maybe just to start off for quite a while, but nobody's rating these items. So how do you not get that right? Say I want to know what user would have rated item B. Will you predict what user would have rated item B? It's very simple. Movement is right, direct is a 5. You know why? Because user n is very similar to user 1. Both have rated item 1 as 4, both have rated item 3 as 4. So I am going to assume that is going to rate item B as 5. Similarly, you will also rate item 2 as 3. Because this and that are similar. That's the whole point of collaborative filtering. User n and user 1 have rated item 1 and item 3 similar scores. They are as similar as I can get. Now user n has watched item B, which user 1 has not watched. So I am going to assume that user 1 will also give a 5 rating to item B, and that's why I am going to recommend item B to user 1 when he logs into the website. That's the most simplest example of collaborative filtering. Trust me, it's not really simple, but you get the idea. Now here's the problem. Would I just take one user or would I take a couple of users for that particular? So user 1 is an active user, right? I am trying to recommend a movie or an item to user 1. I see that it's similar to user n, so I have recommended item B to user. I also recommend item 2, but that will be in a lower ranking because user n has given a rating of 3 to item 2. So I wouldn't recommend item 2 to him just yet, or just recommend copying item B because the highest rating. Now, I should actually technically also consider other users. But the problem, other users don't have the same rating as user 1 has. How is this problem? Actually, very simple. I mean, most of you would have known that this is single geometry. That's machine learning. I mean, that's the sort of machine learning. Most of the algorithms and code that you do in machine learning can actually be done on paper. Where to do it? Just takes a lot. 2 points. How to find a distance? That's how you find a distance. So, if this was user 1, there was user n, and he has given 4 and 4 and 5 to 3 movies. He has given 4 and 4, but I don't know what the other rating would be. So, I'm not going to take the 5 because I don't know what other rating is, but 4 and 4, so those are very similar. So, the distance would be the least. When the 2 points are 4 and 4, so there is no distance between them. So, I am going to basically compute the distance between each of those users. I'm going to compute the distance between each of those users using something as simple as Euclidean distance. And then the item I'm going to recommend user 1 is not going to just item B. It could be anything based on a weighted average of the different movies the other users have liked based on the distance between this user. If it sounds too complicated, let's just say this. This is user 1. User n was very similar to this guy. But you can see that user 4 has also done the same movies, but is not as similar as to user n as he is to user 1. So, say user 2 is here. So, I am going to recommend a weighted average of user n and user 2. But I am going to give more preference to this guy because he is similar to my active user. I am not going to give more preference to this. That's all it is. That's multiple users and that's pure user-based collaborative filtering. Netflix actually uses something called rating-based. I don't know if you guys know this, but Netflix a couple of years back they bought up a competition on Kaggle. They had a $1 million prize for somebody who topped their current competition. They didn't implement that for legal process, but the team which won that was from AT&T Bell Labs, and they had implemented something called rating-based collaborative. That's the whole thing is. So, distributed users now. What's now? Euclidean distance, we also have cosine similarity. They all do the same thing, but it's just that you use each of them for a very specific purpose. For instance, I will use cosine similarity for data analysis usually. Euclidean distance usually for it's basically when the weight of the vectors don't really matter to me. I use cosine similarity. It's not very long. You get the idea. The whole point is to basically find out the distance and how near to the active user each of the other users are. Find out what their ratings for this particular user is. Give them the weighted average as the particular distance between the other. Right. This is something I really wanted to cover. I don't know if it's a good idea, but there are some fellows on Amazon and Netflix who seem like everything in life. They give every movie a 5 rating, and there are some fellows who are just pissed off with their every movie a 1 rating. They are wrong, trust me. This is a problem because they kind of they bring down the entire the collaborative system. If they are given a number, the collaborative system won't work well. Because if you say 500 guys and 100% actually hated the movie, the system is not taking all the movies that maybe it is. So as most of you guys know that whenever you get any data, you got all the data to import and normalize it to make sure that it's followed any things. That's where I'm going to suggest a correlation where I'm just going to normalize all the ratings the guy has got, doing an average, then they process that. Usually makes sense to normalize the data and then. So what this was is most people were, even the lot of people who don't like the movie, a lot of people who they're even a 5 rating, they're even a 1 rating. I normalize all the data, so it gives me a more accurate representation of what it is. Right. Yeah, so this is actually what Netflix, I don't know exactly this Yeah, this chart we had shown for last time. Remember there was RT and commercial and drama and comedy. What if I said, you know what, let's not, because that was content based. Like I said, the problem with content based was they are trying to give a subjective score to a movie, but that's the whole point, subjective. You don't know if it's subjective, these are fields, comedy values, not comedy. What if I could do a list of factors or a couple of factors which I don't know what those factors are, but they can be mathematically reduced. If this sounds complicated, let's just put it like this. This makes sense. Now, say I want to find out the rating user 1 could give item 4, or you know what, item 5. Yeah, you know what, it's good item 4. Item 4 is 1, item 5 is 7. User 1 what? User 1 give item 4. The action 2 is you can do this. This is what you do realize that with this table, actually except for item 5, which actually is not a rating, which is a typical post of all. I can actually give a predicted rating to all of these blanks. You ask how. So if this is a matrix, say this is 4. I'm going to split it. I must split each of these elements into 2 vectors. Let's ask as simple as that. For instance, R43 is 4. That's going to be a dot product of P4 and Q3. Don't get into the maths of it, it's basically I'm just breaking up a number into 2 orthogonal vectors. Not to worry too much about it, there's a lot of information on this internet and a lot of history on this. So what I'm doing is, those numbers which you're predicting instead of blanks might or might not be. The whole idea is to predict it. Prediction always is an error. It's an optimization problem. You're trying to reduce the error as much as possible. For instance, when I said that user would also have 5, but not put it into 1. He put it into 1 part. I'm assuming that he put it into 5. So when I'm predicting these values, they could have a margin of error. Your idea is to reduce the margin of error as much as possible. Works for the most number of data. The highest number of people who are being given this data system does not work for all. You are breaking up this one of these numbers into a vector of 2 orthogonal vectors in dot product. That's all it is. Don't worry about how it's happening because there are libraries to do that. It's a simple math. Now when you do that, what actually happens is, so you are waiting for all of these. And now you also realize that if this matrix was fuller, now this matrix actually had more data. It will make things much easier for me. It will make things much simpler for me because then I would know what to recommend to any of those users, any of those items in a ranking order. That's the whole point. You don't recommend people a 3, you always recommend a 5. Because that's the ranking order. The probability with which he would like this starts with the 5, 4. After 2, you don't. Now, there are questions at this point. How it fails to make these 2 matrices. So it's a log. I've added a link in there's a link in the thing, but each of those numbers is a scalar. Right? This number is a scalar. Divided into 4 orthogonal vectors. And then you can take a dot product of these. So when you have 4, you want to take this, so that's your PU. It's PU, right? And this is your Q1 or QY. The dot product of these 2 vectors is this. Now, when you have the dot product of this and this, if I ask to predict this, you just suppose you have the orthogonal vector for this one because of this, right? Because this is a product of this and this. So you already have this. You already have this. You can make this. Let me just make this a bit more. Which one do you want to put? What's the item? User item. 4, 2. User item for item. User 2 for item 4. User n for item 4. You have this. You want to make a orthogonal vector for this. Just with this scalar, right? You already have this. You want to make an orthogonal vector, you can always make 2 orthogonal vectors. Because why am I take the orthogonal vector from this Q, from this one? You have for this one. The dot product of the 2 vectors is one bound to some relating node. In the end of the
question, in making orthogonal vectors, consider for any one user, if you use the data that you have by half, say you don't have a how adversely does it affect the prediction at any given point? Consider you have got it for one product. Say if you're migrating that same pattern for another product and suddenly the data but it becomes half of what it actually cost for any one of the any user, anything that it was.
Yeah, so this what actually happens is when you take the orthogonal vector for say 4, but if you take the orthogonal vector for say 3, right? Just it's not makes sense now. It's orthogonal vector for 4, right? That's n1, right? You want orthogonal vector. This orthogonal is going to be different again, right? You can't just say this is an orthogonal vector. I'm going to just use the same orthogonal vector again. The whole idea is to reduce the margin of error. So you are going to start assuming this is not something which is this is basically optimization problem in the way that you start off with some values initially. These values that you see, blanks, you don't calculate these values initially. Start off with some values, you just put them 2, 3, 1, 4, 5. and now we start related to money.
So the values which come closest to the most possible output, you are seeing that in that.
Yes, the best way to do it would be actually you remove a few of these things already, right? And then you start creating the values on things so that you can at least make the smallest box out of it which will cover all the values, and see that the greater values you have after say n iterations is as close to the original values. That's the training set. You are taking a part away of the training set and you are running the iterations to see how close it comes to 3.77. If it comes to 3.77, I'm good. Did I answer your question? I have added a link in the last slide. If you have looked at it, I want to put this presentation there as well. It has a lot of papers you should have a look at. That's the best thing about it. A lot of things. After the word over and myself, they're good. Right, so let's open what the post of call this. Product post start and user post start. I think already covered this. Right. Okay. Do you think it's going to take money to start recommending personalized recommendations to each new user who comes in? Or do I just show them? Say, these bunch of people have already been on Spotify. These guys are coming today. Based on what these guys are doing, or these guys are rated a few products like trending or popular or whatever. I show all these 8 guys who come here the same list of materials. Wouldn't that be easier? That will be much easier. It will be easier because I don't have to spend money. I don't really care who likes what. They can choose by themselves out of those products or out of this popular trending. Some of them would like what popular trending numbers are, which is usually not great. But that will be much simpler and positive. Because then they start living on things they want to do, and then from there on we take it over. But that's something we call non-adaptive. It does not adapt to new users. This is it for new users. So one of them is ask to rate. This is so what's Spotify does is when you go on to sign up a new account on Spotify, it asks you to rate songs which you already listened. You might have not heard the song before, but it asks you actually explicitly asks you for an explicit rating. Remember the difference between explicit and implicit rating, right? When you actually give a star to that song, it asks you to rate that song because Ghana, Wink, nothing Wink and Sawa, what I realized is they ask you for genre and the language usually. Genre and the classical Bollywood, that kind of Ghana is the same thing. Yes, genre and language, right? Spotify asks you to rate a particular song from 1 to 5 explicitly. You can sign up. It does that. We used to do that earlier back. I don't know what to do now. That actually makes things very simple because when you're asking the new user to rate a song, you already know his likes and dislikes. Now, based on his display data and the search history he is going to do on his app, I'm going to find users similar to him because there will be some user who is very similar to this guy. Because somebody will like classical, somebody will like melody. Start recommending that guy. See what is, if it doesn't click too much, great. Start recommending classical, but not melody. Start recommending melody, but not classical. Keep sending recommendations. He is going to keep clicking and clicking on different songs. The moment your new user does not clicking on more than say 15 or 16 songs, a profile is made. That's the whole start problem. It is not called keep staying. The APS stays. But usually it is solved because after a point of time when the user has crossed a certain threshold, the user of this cloud system takes over, the matrix takes over and all of this. Yes. This is actually very funny because whatever is another Ghana does that, it shows you the new Bagi for instance. So listen to that. Or it will also score at again, it's cheap. Problem being that I might not like Bagi. I might not really need volume music. I would send something else. So when there's recommending the same list based on which is the most popular to all these 8 users who come for the first time. 4 of them not going to stick around. They are going to go somewhere else which understands them better. But I'm not going to go and start searching for the songs. It's not a current list. this will work with adaptive. So when I say that you come Spotify or you come to Ghana or Netflix, and you have clicked on something. Now, based on what you clicked on, so for instance, Amazon, you have gone to Amazon, you have searched for Nikon DSLRs, and you have started clicking on Nikon DSLRs. That's your first click. After Nikon DSLRs, you have clicked on Canon DSLRs. That's your second click. After Canon DSLRs, you have clicked on mirrorless DSLRs. That's your third click. Your profile is made now, so you start recommending cameras. What is it going to recommend? Which cameras are going to recommend to you? Two ways. One, what are people from your geolocation browsing camera? How many of those are browsing cameras? What are the cameras they are browsing? They are going to start recommending that. That's how a ghost problem is being solved right now. So a lot of work in progress actually. A lot of those are going on. But for new users, that's how a ghost problem is being solved right now. It's also content based. Metadata. You don't have to know the content of everything. When I start with cameras or when I start at the first movie I click on Netflix when login for the first time could be say something like La La Land. I like La La Land. I just click on La La Land because it's showed up to me. And now it is once I click on La La Land, users who have clicked on La La Land, it is going to take all those users who click on La La Land from your geolocation. Rank those using an IPS classifier, which is just basically predicting what is the probability that you could also like this. Start recommending those things. You want to give a third movie, fourth movie, movie, after a certain threshold value, the user based value system takes over. And your system. Yeah, at this point. I think something called information gate to clustered neighbors. The problem with geolocation, I tell you, for instance, classified sites, for instance, wouldn't be lost in those classified sites. You just search for ads. But new ads are more relevant to customer users coming rather than old ads. The reason still old ads are being, for instance, OLX. OLX, suppose you don't want to search, you don't want to sell anything, or you don't want to really buy anything on OLX. You just go OLX to see what the prices of the new product vendors. There are two problems with the profile, not with the profile. So I don't know what to recommend. Second, if you are doing this with the incognito mode in Google Chrome, because I don't have location data, geolocation won't work. So this is not like I said, it's not a one solution fits all problem. This is a recurring problem. Also, one very interesting thing I was looking up yesterday is that when you log in through, if it has created your profile on, if Netflix has created a profile on desktop, but you are doing something completely different on mobile, there is a good problem out of it. You are watching war movies all this time. Suddenly from mobile, you are watching only long forms. That's a question about microphone. What recommend you next? I would recommend all. Obviously, the two ones you have watched, but I'm also going to say that you could also watch this. So when Netflix says, there are two tabs on Netflix. It is saying something like, users also watched this. That's user discovery, which Netflix is already telling you. The users who watched this have also watched this. This is execution root mining in Amazon. You want a phone, buy a mobile device. You want a camera, buy a tripod, because that's what 90% of users are doing. That's user discovery system. But then how to discover new things? Because again, now Netflix, what it does is, that's why Netflix is modified because so for instance, ROM mouse, right? When you listen to ROM mouse, it doesn't just suggesting data selection and ROM mouse or what the users are like, it starts suggesting something completely different at times. And I have started listening to metal and it has gone all the way to progressive electronic plants. I didn't know this genre existed. How did it start discovering this? That's the whole point of recommendation tips. You start discovering stuff which you don't know existed, but you might like. How did I discover this? Because some user would have known that song and you would have gone and done that. But then how is it recommending that to you? Because you have to keep scrolling this, keep scrolling, you realize that Netflix and Amazon is never ending. Keep scrolling, this will not end. Spend your whole life. Next time on you can watch this. That's the whole idea. Yeah, that's the things I have a look at. I have created a few links and put up the discussion there on that. A lot of papers on that you can have a look at that. And if you intentions now, intentions now also main. Yeah.
So if you look at products like say Sound or Spotify, if you look at products like Sound or Spotify, the incubation period where you can actually go from having a data on someone to actually building a profile is very short as compared to what are running in the time. Because over there, consumption is actually spreading. So how does these techniques like for pushing through
So I'll explain this problem. I'll explain this answer with different examples in the data. There are very good examples. Usually you know what you want to do. Usually you know what you want to do. It's not the same chemistry. You don't know what you want to watch. You have an idea, I want to watch a scary movie. What's scary movie? You don't know. Right? Now, when you go on Amazon,
is it actually like that? Because I have particularly seen a lot of people go specifically for a movie since they have this.
Specifically for a movie?
Yeah.
Or for streaming?
Yeah.
Most of the time you don't get that. Okay. Usually, for streaming, I mean, you can't say, I want to watch and just go in. It's not there. It's not there. Binge watching, that's what works. Usually when you do content streaming, you want to check out new stuff or something. This new series, complex processes. That's what it's recommended. When you go to Netflix, you see this banner. Right? When you click on different approaches, on Amazon, at least say you click from A, I don't know, from umbrellas to the car windshield wipers, within a certain limit. I'm not even going to consider your data for my user-based collaborative algorithm. Why? Because so all these recognition engines, they have a time compression factor. You have to consider something random because that's what the bot does. We want to discount those kind of erroneous data into the algorithm because if there are a lot of people who are browsing to the algorithm 150 products in less than 3 minutes, I don't get any insight about it. I don't get any insight about it. On a content streaming thing, that takes a bit of time. That takes a bit of time because a lot of times what happens is, say, on sound, you have seen the song but you not click on play. Alright? Second song you click on play, you listen to part of it, but then you the last one, you listen to part of it. You have to just play. 5, 3, 1. Right? That takes time. So the timing for e-commerce or content streaming, even though the user-based collaborative system works, basically the same thing, the complexity is different. Also, every time now, since I know what genres you like, since you say you're a Bollywood listener, I'm not going to recommend you something. I would recommend you something with a popular or trending tag, which is there in most of the music websites. It's a trending thing that you should also listen to this. Something like Ed Sheeran, Shape of You. A lot of people are listening to that, but I know that you might not like that. I'm not going to recommend Ed Sheeran, right? So when you say that how much time does it take? Usually I would put the number at around, see, if you're actually using the ask to rate and you're actually creating a profile after you're setting up, you're asking all these questions, your profile doesn't do. What your click stream is doing is basically trying to build on the profile. That's a constant. But on Amazon, you don't really push up anything. So that takes a bit of time to get that profile. But usually about 4 or 5 clicks, I think the rate of that 5 to 6 clicks later. So as you keep moving to different products, and it has damaged with the extreme and it's realized that you zero because it's basically a decision. As you click on a camera, yes. Just click on a camera, what camera has clicked on? Yes. Now what camera? So it's a basically a decision. You will be put into one subset of users who have the same or very similar picture to you. Say 5 products you have clicked on, and there are people who are very similar to them because 4 products. I'm going to put into that. I'm going to what these guys have done. I'm going to tell you that.
So, if you're looking at that distillery, how does it vary? For example, if you're going to Spotify music, then they know that you have a certain kind of taste, and that is what your entire experience is based on. But if you're going to Amazon, you might actually go for, say, expensive phones and cheap clothes, and vice versa. So, does it actually matter? How does that difference actually?
You're asking if Amazon has Spotify.
No, I'm saying that when you go for these kind of platforms, you might go for a particular product which are one of the most expensive ones, and you might go for say maybe clothes
That's the whole point, right? So, like I said, if you wanted to do a bike for hours, all of a sudden, some 5 months, you are buying very expensive clothes. All of a sudden, you are buying only very cheap clothes. That's the most idea. Because now the algorithm has to redo your thing. Because your historical data says that you are a guy who lives a good life. Now you suddenly become poor. So how to start developing stuff to you? Because I don't know, because your historical data is different. But now there is a similarity with people who have like similar stuff to you. They are not in the same thing. You are a gray sheet. That's a different kind of problem again. That's something we call, like, this is a question problem. Gray sheet is a different kind of problem. That your profile basically is 50-50. I can't really start subsetting you into one particular group. It keeps varying. That's a different sort of problem, but yes. So I'll give more preference to your, usually managed. You give more preference to the most recent data than the older data. So now I'm going to start recommending. Once in a while, I'm also you can see that, right? When you click on something, when you search for something on Amazon, and when you log into Facebook, you have to make my trip. Do they see that? You search for something on Make My Trip, you buy a ticket or something. Maybe you don't buy a ticket, but when you go to Facebook, it shows up an ad. That's the whole thing. It's most recent data. Search from Chandigarh to Mumbai, and go to Facebook and Chandigarh to Vizag, and do 2 other searches. It's going to show always the most recent one. That's how data works, and that's how it's going to start making the profile all over again. That's a good start. But again, when you have 3 clicks, your profile is just green. It does not mean your historical data is green. It's only when because you could compare that any time. But suppose you don't do that for some amount of time, it's going to start attacking whatever it is. Alright, that's enough from my end.
So there's another question.
Yeah.
There are deal sites nowadays, and a lot of users go to the deal sites and click on some of the deals which are on the e-commerce sites. Now, what happens is it screws up the user collaboration, because now generally when I go to Amazon, I search for a certain set of products and sub-products and sub-products. But when I'm going through a deal, the kind of products would be very varied, and wouldn't that screw up this algorithm of collaboration-based users and recommendations on that? Because now I am clicking very, very different items just because there is a deal available. I might.
Is that deal site going through Amazon?
Yeah, deal sites have a link to the Amazon product, and I go to Amazon, which is having my user login.
Yes.
So that is also considered as a cold start again.
Depends on how consistently you do it.
Nowadays, this.
And if you're shopping on Amazon only for third-party affiliate links, yes, then I would start recommending products which only have links.
Okay.
I would start recommending products which have, because Amazon, technically speaking, when you say this problem, Amazon does not know if there's a deal on this product or not. Because that's the proprietary information of the dealers.
Yeah, of course.
But what Amazon is going to do now is it's going to find out similarities between these big products and start recommending these kind of items to you. Right? Because these could be anything. It could be anything. But there will be a pattern to it. Because a lot of users like you who are also going to deal websites would have had a very similar history to you. So I'm going to take those users who have a very similar history to you, start recommending these items. 99% of the time, those items are exactly what you want. Because these users have also got the same needs. You're not only going to these sites, right? They have these sites. So that's what it is.
Right. Thank you everyone for coming. Thanks DataGiri for inviting me to talk on interpretable models. Before we start getting into the topic, I just have a few questions to ask. How many of you have taken any machine learning course? How many of you are PhDs or come from academia? Okay. Most of you are in the industry, right? Working as a data scientist, data miner, or as an analytics professional. That's good to know because I have experience in IT and as well as in academia. So my name is Manish Kukreja and my website is datahacks.ml. You can find lots of information about me and my projects on that website. What I'm going to talk today is interpretable
interpretable models, and what we want to do is I want to divide this talk into 4 parts. I want to talk why we need them, do we have any techniques, what are those techniques, and how can we create a system like that. So since most of you are familiar with machine learning, have you come across such a thing like this? Have you ever written a report or analytics report like this? Just by show of hands if you've done that. Okay. So if you look at this report, it is about a data set, which is airline passengers data set. What this report is showing you is an executive summary which statisticians really like. What it tells you is it describes the data. So what this data is, it has some components which are listed down at the bottom, which has got like 4 components in it, a linearly increasing function, it's got periodicity inside it, it's also a smooth trend, you can see, like a sinusoidal wave if you zoom out a bit. And you can also see there's some noise in the data. And if I tell you this report was generated by machine, would you believe? So there is a system already which reads the data and which also can decompose it into various components and can show you that. So in a human readable format, which statisticians like, if you can get such an information beforehand, just assume if you have a higher dimensional data which has got like hundreds of rows and thousands of columns, such a data set like that, and if you get a report like this, would that be handy to you to start doing your recommendation systems and whatnot? Would that be useful, right? No? Yeah. Good. So this is what I'm going to talk. We will be discussing a lot about these things and how we can get that sort of a report. Okay. So let's just first look at why do we need interpretable models. Most of you are machine learning engineers or data scientists, so you must be familiar with this situation. A business analyst or a customer comes to you and asks you, is this your machine learning algorithm? And you say, yeah, this is fine. It doesn't give me the right output. So what do? You just shake more, give more data to it, run a few more times. If this is what we are doing, we're doing it very wrong. Right? Because we ourselves don't know what our models are. How can we assume the customers or the users would be using it, would be willing to spend money and want to use it? And now we are seeing more and more people want to sell their products or recommendation systems to doctors, lawyers, so that they could use them and recommend to their customers. Just imagine if you don't understand yourself what your model is doing, how can a doctor, prefer your algorithm over his own experience? So what I'm saying is that these systems are very, very delicate. A recent research published in February 2017 showed that if you have a classifier which is doing machine learning, classifying images, if you just change one pixel in that image in the input, the class changes very from a car you can get an aeroplane as a prediction. So you're just changing one pixel into that and you're getting a totally different class with a very higher confidence value. This is very, very scary, right? We are thinking of self-driving cars with cheap hardware and everything. Just imagine you're driving on the road with a self-driving car and suddenly there's a jitter in your camera stream and you start hitting people. Right? So we don't want to have those sort of systems, but we want to start with all of those. So right now, machine learning community has been doing these sort of things, and now it's, I think, a good time to now look into the interpretability or explainability side of it. Right? Second reason why it is very important for India is because of this. There are lots of companies want to start their research centers in India. So if you think we would be just doing the old kind of an outsourcing job, we will not be doing think you are wrong if you are in machine learning or IoT or analytics. Because lots and lots of companies are going to start research and core services in India as part of Make in India initiative. So we have to gear up ourselves and start looking into advanced things as well. So this is, I think, I'm going to start the talk now. These were like the basic things that I want to show why we need interpretability. And let's play a small game with supervised machine learning. I think most of you played with it during your courses, right? Let's see what supervised machine learning is in a very quick thing. You're given a set of labeled inputs. What your task is as a learner is to understand the mapping between the input and the output. Basically, the columns labeled as x1, x2, x3, and column labeled as y. So this is what mapping you have to learn. Once you learn that, you have to either classify, basically you say yes or no, or you have to do a regression which would just throw a number, for example, what's an average salary or what would be household income or price of a car, something like that. So let's play a game on classification. On the screen you'll see two data sets. One on the left is an image data set, the one on the right is a number sort of data set. I will be talking more on the image one. So you would see you have two classes, yes and no, and you have a bunch of images. Now you be the learner and tell me where would you classify this person in? Yes. How many yes? No. I don't know this one. Some people are not very clear. Are you not following supervised machine learning, or you think the answer is no? No? Okay, so if you think the answer is yes, somebody can say why they said yes. Yeah, Robert.
All the purple and the shape is not on the other.
Yeah, same explanation. Yeah, so you see all the blues or the purples on the yes, so yeah, okay, I see a yes here. Why not? How about this yellow donut? No? How many no? Okay, see, how many yes? Any yes? It's difficult because you can see the shape of a donut on the no side and also on the yes side. And you can see the color yellow is on the yes side and also on the no side. So you can't just say yes or a no to this shape. What about this blue arrow? Right? You see an arrow on the no, but you see all the blues or the purples on the yes. So it's very difficult for a learner as well to just say yes or a no. Right? Now we come back to this problem. Let's see about regression. Sorry. So in regression, if we are having a bunch of real valued inputs, which output do you think is the best? Do you think fitting a straight line to this particular data set is good, or fitting a curved or quadratic equation on this data set is good? Exactly, right? I don't know your training data or test data yet. So we don't know whether the straight line would generalize better, whether these observations are noisy observations, right? Like, we need to consider those things as well. How, when your model would generalize on unseen data. Right? So it's not a straightforward, again, data looks like curvy, you have to put some curves, right? So it's not like that. So again, another comic thing is, like if you have something like this. Right? So you can't say fitting a straight line works better or fitting a curve or quadratic works better. You need to also assume as the modeler that how well my model would generalize. So what I'm trying to say here is that as a user of the system, I want the true meaning of the data that I'm giving it to you. I want, why did you take that, why are you taking that decision? If I'm a doctor, I want to know what happened in your decision-making process that you are suggesting me this particular drug to this particular patient. consumer to be having trust on your system needs to give some sort of an explanation. And from a developer's point of view, the motivation is if you have interpretability in your models, it becomes easier for you to debug it, right? So I have two questions here for which I'm going to talk through the session. Is that one, we need the models which can generalize better on unseen data, because our own data could be noisy. The observations that we are getting, the model structure that we have, for example, deep learning network, it could be very uncertain. So we need to model uncertainty in our data, in our models. The second point is because more and more work is going to come, we don't want to be doing the laborious jobs of spinning the line, filling the curve. If we have a system which can do those things for us, we could be doing much more, right? So I want you to think about, we need something automatic and we need something which can explain it automatically. Okay? So there is one technique or one type of modeling which is called probabilistic. So rather than just saying yes or no, if you can give me some sort of a confidence, if the algorithm gives you some sort of a confidence value, it would be good. Then you at least have, some understanding, or you can put a threshold then and then let the user decide what they want to do with that decision. So probabilistic modeling helps you to represent the uncertainty in the data, right? And how it does is it uses the age-old probability theory. Once you use that probability theory, what you can do is using the Bayes rule. How many of you have heard the Bayes rule? Everybody, right? So using the Bayes rule, and we can do the inverse probability, we can infer the decisions and we can also make the prediction. That is the goal of our all machine learning algorithm, is to predict. It's not to explain only. For statisticians, it's more on the explanation side, but for machine learning, it's more on the prediction side. But what I'm trying to argue is that we should also be aiming to the explanation more, because then the trust will be developed by the user community. Let's just quickly see Bayes rule. We already know. Bayes rule is just handing out a probability based on something that you don't know, which is the hypothesis, given that you have got some measured quantity. So the point that we all should remember, the data that we get is an observation, it's not the actual fact. And all our models are just an attempt to go to the reality, to find out the true meaning. All the models are wrong and ours are true, right? So what we are trying to do is we are trying to model that. So don't just be hard on your data, oh my data is totally right. As Arunabh already said, that you could have users which could give you all 5 ratings, all 1 ratings. Now, would you want to trust that data? That's again an observation, right? As a model, your model should be so robust that it handles that sort of end worst case scenario, right, or edge case. So in order to probabilistic modeling, we can have 2 ways. We could use parameters in our model, just like we do in linear models and few others. Or we could use a non-parametric model, where your models, they do not depend or they do not have a fixed number of parameters. Their parameters, they grow as you feed in more data. For example, deep neural network can grow larger if you feed in more images to it, right? You have to increase your size of the network to accommodate that. So what I'm saying is each of those neurons has their weights. So those weights could become your parameters, and then you have to increase the parameters because the richness of your data is increasing, and so that your model should also go up with that. So I really like the non-parametric one because it helps me generalize better, and this is where we're going to discuss more on. There's a niche parametric model which is a Bayesian type. We've already seen what Bayes rule is. It's given the data, check your hypothesis, right? So the framework is pretty simple. If you have a prior belief, feed in some data, you get the posterior, you get the true answer. So if you use that sort of a framework, and if you use non-parametric models, there is a very nice process called Gaussian process. So this particular modeling, Gaussian processes, they encapsulate all these things. It gives you nice generalization on the data that has noise in it, outputs probability, which is useful. It is also interpretable. So you can interpret from the model what the model is thinking. Okay, so this particular process, Gaussian process, has all these properties that I was talking about earlier. What I already spoke. So now that we've seen why we need interpretable models, we've seen how we can get like using a probabilistic model. Now let's see what are Gaussian processes. Has anybody worked with Gaussian processes? Yeah. Does anybody know what's a normal distribution? Yeah. So let's start with the. So there are various ways of explaining or starting off what's a Gaussian process. The approach that I like the best is using graphs and images rather than the words and the mathematics. You can all go back to the papers and read about it in your own time. But this, I think, is widely understandable. So let's say if I want to see something like I want to measure my heart rate at every 7 o'clock in the morning, and I want to see how healthy I am or I'm not. So I would have a prior belief. I would say, yeah, on an average, I'm around 60 in the morning. My heart rate is around 60. So that's my prior belief. I put that into a probability. Then I do my measurement. I do it on Monday. It's around 62. Yeah, good enough. I do it on Tuesday, Wednesday, and Thursday. Now I have some bunch of data to me. Right? What I want to do is now apply the Bayes rule. Once I apply the Bayes rule, I get a posterior which is saying, prior belief was not that good. This is what your heart rate looks like in the morning. Right? You're on an average around 60, 63, and you never go below 50 or above 70. Right? So this is what a normal distribution is. It's like it is telling you it is very sharp in the middle and it tapers off very rapidly at the edges. Right? So it's a normal probability distribution, and many people just call it Gaussian. So in again this talk, if I just refer Gaussian, think of this it's also famously known as bell curve. So in the previous example, we had just one data. Every morning, 7 o'clock, I was collecting my heart rate. Now I want to improve my project. I want to have 2 observations every day, 7 o'clock and 8 o'clock. And I want to see what happens with that. Right? Is there any correlation between heart rate at 8 compared to heart rate at 7? If I want to do that, then I have 2 variables. And that is called a multivariate Gaussian. Earlier one is also referred as a univariate Gaussian. Right? So if I have a multivariate Gaussian, it would look like this in 3D. It would look like a real bell, not just a curve. And in 2D, it would look like a contour plot. So this is my prior belief. What I'm saying is that if I have a higher heart rate at 7 o'clock, there are more chances that of it being higher at 8 as well. So these, again, I'll do some observations. I get my data. What I do next is apply Bayes rule. I get posterior distribution. And this telling me again, my heart rate is around 63 or 65, and then it also remains the same for 8 o'clock. It goes up around 7 or 7. Now you want to extend this project, right? If you mean you want to. So what you want to do is that you want to take your measurements not just at 7, 8, but 9, 10, and 11. And now you see something. Right? If you try to connect these blue dots, you'll see a curve, sinusoidal wave of sorts, right? If if you want to connect the pink ones, the blue ones, you get a different sort of curves, right? So what I'm trying to say is that we don't really need to be thinking of one variable, we can be thinking of multiple variables, right? And if you have something with respect to time, it becomes a time series. So now if you have a time series data, what you can do is you can put a prior onto all those functions, all those variables. So this prior is like this. It's got a mean in the middle and it has an envelope of variance, right? And this is our Gaussian process. In a normal distribution, what I do is I pick an observation, 1, 1, 1. In a Gaussian process, I draw the entire function, the entire curve, right? So rather than drawing just one variable, it becomes a Gaussian. If you are drawing entire functions, it becomes a Gaussian process. So how Gaussian process regression works is that you don't have to be rigid now. You don't have to take your observation 9, 10, 11. You can take it at 10, 30, right? So I took an heart rate observation at around 10, 15. That becomes my data point. Then I took it around 11, another data point. So what's happening here is as and more data points or information I'm feeding into the model, its confidence or its variance is reducing. And it is also taking a shape form, right? It is taking a smooth form, so it's not linear, it's not quadratic. It's not a simple line fitting problem. So it preserves the richness of your data, and it is also not to the point, like it's not rigid. It is not taking this particular observation into consideration. Why it is not taking this particular observation is because it wants to generalize it better. It is possible that this was an erroneous or noisy data. So using Gaussian processes, you can create models which can encapsulate these richness in your data sets, and it can it's pretty easy actually. Yeah, few hands I saw. The lines of code is not big, like 4 or 5 lines to get a Gaussian process. The difficulty in people using it, why people have not been using this is because it's very difficult to craft it. When I say craft, is the Gaussian process, or in short it's called GP, is completely defined by its mean, the line that's going in the middle, and the kernel. The kernel is like a distance matrix that Arunabh was talking about, that you have to calculate the distance or the similarity between the 2 points. So similarly, you have to compute the similarity between all the data points that you have. And if you don't do it right, there are chances that you end up getting a very different Gaussian process. So up to now, people have been doing it by hand. I'm going to talk about a system which does it automatically.
Like a basic question is, what is the, when you move from that single data point thing to the Gaussian process, what is the objective that you are trying to achieve when you make this transformation?
So the objective was, in a single Gaussian, we were drawing.
Yeah, so those are
unique. So you have one random variable. Now if you have more than one random variable, which is very often we have multiple columns, right? If you are in a time series data set and you have multiple columns, then you have more than one random variable.
So this is basically converting that discrete variable into a more continuous.
Everything is continuous in Gaussian. Everything is real valued. It's just that you have more columns. You have more dimensions in it.
The axis change, right?
It's just a representation. The data remains the same. Earlier I had just one column, heart rate at 7. Now I have heart rate at 9, heart rate at 10, heart rate at 11. So I have more columns, right? Okay. You're getting the data set. Yeah. So if you have more dimensions in X, you want to have a tool or a model which can encapsulate that. So that's why we're moving from this. Yeah. And if I directly start mathematics, you may or may not follow that. So going from a single univariate, if you look into this perspective, this intuition helps us building why we need Gaussian processes in the first place. Yeah, so that's the summary slide which kind of encapsulates that, what we have so in a univariate, the distribution is over one real value or random variable. In a multivariate, we have more than one, pairs or triplets or triplets. And in a Gaussian process, we no longer have a limitation on number of variables. It could be infinite, but mathematicians don't like to call it infinite, so what they say is it has to be finite but unbounded. So as long as you can fit into your memory, yeah, it's fine.
So in the previous graph, the Gaussian processes, all of these are dark blue. So isn't this distributed day-wise, Monday to Friday?
Yeah, so this was particularly, I'm saying, on Monday.
On a Monday?
Yeah.
Okay, so what if you take all the days in this particular way?
So that's the error bar that you get. So most probably you will fall into this. So you don't have to be rigid whether I'm taking it on a Monday or on a Tuesday. The error bar would adjust.
So can't you get some inference about a particular day if its heart rate is too much or too less or something like that?
Yes. So in this
particular graph.
In this particular one, because I'm not distinguishing between the days,
right.
I'm just distinguishing between the
If you do it.
If you do it, then you have more than one Gaussian process per day.
Okay. It cannot fit in a single graph.
No.
Okay.
Because then your data set is very different.
It
becomes, I think you have to arrange it in this way to get one Gaussian process.
Right, so you can do something.
Yeah, if you can arrange it in that way, then it would work for you.
Right.
Because that's what I was saying, it will not work on categorical data.
Okay.
It has to work on real data.
Okay. Yeah.
Because you're creating categories Monday, Tuesday, Wednesday.
So you might as well shift like for Monday and then for Tuesday.
Yes.
The same graph continues.
So you have maybe 7 Gaussian processes for each day.
Right. Thank you.
If you're looking at time series data in Gaussian and say you are continuously shifting between say on a scope of 7 days, maybe to a month continuously, then a year in that amount of times.
Right.
Then if you're using say other functions like maybe log code, how does it work if you compare to those kind of functions?
I think that would be very different because that's what I was discussing again. If you want to drill down or drill up or move up, these sort of techniques would not work or are not applicable to this domain. For Gaussian processor to work, you need a data set which has real values and it could have more than one column. So like if you are talking about a person's height and weight, and if you want to see what sort of Gaussian process, because in this one I just took one variable which is my heart rate, but you can take more than one variable. So your model is defining how fit you are based on your weight and height every day.
So you cannot do that as easy.
So you can't go drill up and drill down because
it's not that makes sense.
Yeah. Alright, so the important takeaway message from this particular section of the talk is that a Gaussian process can be completely defined by the mean that we saw the middle line and the covariance matrix, that is the distance between the data points. Okay, so if you have these two information, you can create a Gaussian process. It's very easy to do that. And then once you create it, it is very useful for you to do predictions on unseen data. And it can also incorporate the uncertainty in our data set. What to do with the yellow donut that we talked about earlier? Should I put a quadratic equation or should I put a straight line? Those sort of things becomes easier for you to then use.
Why are we considering only the Gaussian model? This is just a, you are considering that every data point is like a Gaussian curve, right? So that is the model we are assuming. What if it does not fit that model? What if it's not Gaussian?
Right.
Then what happens?
So you want to say that if it is not Gaussian probability, if it is something different.
Something different, say it's your model, then the model will not fit the data.
Right. As long as you can do the Bayesian inference, it would work. So we can fit into different type of probabilities into it as well. So there is a good toolbox called GPML, which is available only in MATLAB and Octave, which allows you to play with the likelihoods and the different type of probabilities. So you can play with those and see what happens. But for I think for the brevity of this talk, I'm just sticking to the Gaussians. Because most of us are aware of Gaussians and we can directly relate to it. Alright, so before moving on to the next part, I talked about two questions. One was, how can we make models incorporate the uncertainties that we have in the data? Second was, how can we make it automatic so that many data scientists can utilize that, right? So the answer to the first question was using probabilistic models, specifically Gaussian processes. The answer to the second is something called compositional kernel search, or at the end I would say it has a very nice name called ABCD. So what's a compositional kernel search? It's basically representing your entire data set into rich kernel forms. So remember earlier I was talking about a Gaussian process has two things, a mean and a kernel matrix or a covariance matrix. So that covariance matrix is the distance between the two. So if I could find a rich kernel which can satisfy my data, I got a good Gaussian process, right? Now how to make it interpretable, how to make it search that automatically without need of an expert is this algorithm. So this algorithm has a lot of components into it. This algorithm was created by a group in Cambridge University, UK, machine learning group. They call it automatic statistician, and what they do is they use something called language of models. Up till now, we don't have such a language, and I don't think we would ever have. This is for the machines. So the language of models, what it does is, if I want to explain in a nutshell what it is doing, I could just use a whiteboard. Let's say you have a data set like this. Right? What you're seeing in this data set is it has some peaks here. Right? They are kind of repeating, it had a peak here, but it was kind of small, and then the peaks were, up big. You could see them, like they are amplified. Right? So you can see in this particular data set, there are a few features. First is increasing linearly, then you have some periodicity, right? You can see that, right? Yeah. So how can I create a kernel which can incorporate these two features? What I would do is, I would first break it down into simple kernels. And those kernels are like, these are the 5 basic kernels, right? One is square exponential, just remember it as a smoothing kernel. The other is a periodic one. Third is the linear one, then the constant, then the white noise. So these are just the kernels. And remember in a GP what I said, if you have a kernel, you can draw functions from it. What do I mean by draw? It's like you have a bucket and you're putting your hand inside it and you're taking out something from it. So you're drawing, right? So you have a kernel, what I'm trying to do is I'm drawing. So when I draw two functions from a squared exponential, I could get something like this. These are smooth curves. It could be varying in any shape or form. Well, these are smooth curves. These are these two examples here at the bottom. If I have a periodic kernel, I could be drawing something like this, which repeats after some time. If I have a linear kernel, then I could be having increasing or decreasing functions that I could draw. If I have a constant, this would just form. If I have a white noise kernel, I could just take out some noise, random numbers from it, right? Now what do I do with these 5 basic kernels? I do something called search on these 5 basic kernels. First and foremost, I would try to apply all these in this data set. When I apply a linear kernel, I would get some probability value or a maximum likelihood of that kernel. Then I'll apply a periodic kernel. I'll get some value of it. Then I'll apply a smooth kernel or an SE. Then I'll get some value of it. Then I'll apply a constant, again a white noise. So what I'm doing is when I say I apply, I put this as a kernel matrix into my GP, and then I run the GP, I get the maximum likelihood for that data set. Once I have maximum likelihood for all of these, I see which one gives me a lowest value. There's something called BIC. Have you heard of BIC? Bayesian information criterion. Right? This is like an Occam's razor. It will discard any complexity you have in your model, and it will give you some number. And the lowest the number, the better the model. So what I'll do is I'll get the BIC from all these individual kernel, individual GPs. Whichever is the lowest, I'll choose that. Then I'll continue. In order to continue, I need something. What I need is I need operations. So what I could do is I could either multiply or add any other basic kernel. So I could create something like linear into linear. What becomes what happens when you multiply two linear kernels? You get a quadratic kernel. Once you get a quadratic kernel, you can draw quadratic functions from it. Similarly, if you have if you add linear with periodic, you get a periodic trend on a linear kernel. So you can draw functions like that. Now you start seeing you can encapsulate such richness into very simple operations. And the good thing about Gaussian processes is, like, if you add two Gaussian processes, you get the result is also a Gaussian process. If you multiply two, the result is also a Gaussian.
So when you move back to the previous question,
Yes, sir.
so right now you said, like, you will try to fit either of the kernel. But for the best fit, I think we should
Have to. See? So that's what the algorithm does next. That was iteration 1. In the next iteration, what it does the operations. So it will do linear. It will do the operation only on the one which gave the least. Let's say the linear one gave the least BIC. So then I'll expand that tree. What I'll do is I'll do linear plus linear. I'll do linear plus periodic. Linear plus smooth, so on and so forth. And then again, I'll compute the maximum likelihoods, I'll compute the BIC score. Whichever gives me the lowest is fitting the model well, I'll branch out. So what I'm doing is, or the algorithm is doing, let's get that. This is what the algorithm is doing. Starting off with the base kernels, applies all the base kernels, gets the BIC score, whichever is the lowest, then uses the operators, plus or multiply, gets the second layer, gets the third level, gets the fourth level. So slowly and gradually you will start seeing you're trying to capture all the richness, all the local features, and all the global features that you have in your data, and you get it in a way which is interpretable. I know what is a SE, I know it's a smooth function. So it has some meaning to it. I know what's a linear kernel. It has either increasing or decreasing. So whatever model I get at the end, it would not look like beta 1 plus x1 beta 2. I really don't know what that beta 2 is or beta 1 is. Why my model has chosen that particular coefficient? Because it was just fitting it well. But then I can't explain that to a doctor. I don't know what's beta 1. What's this number? I can't tell him, oh, this is the neural network, it recognized some problem in this part of the chest, that's why this is the recommendation. So if I have a model which is interpretable by the developer, as well as it can create such a nice report, then the trust level goes high. Yeah.
You still have to correlate that linear this thing means something. That needs to do with yes.
So that's why at the start of this project, the team decided to just start with 5 base kernels, which are easily understandable. You can easily relate those to simple English terms. But if you try to do it manually, you can use any number of kernels or any complexity of kernel, because there are a lot of kernels handcrafted by the statisticians which you can use, and it will give you amazing results. But you can't translate them easily as to why that works. So this is an example of very popular models that you see on the left, and on the right you would see the output that we got from ABCD. Right. So if you have something like additive model, it's just an addition of smooth functions or smooth curves over the dimensions that you have in your data. So you can represent very rich structure from your data in very simple form. And that you can put it into an algorithm which can do it automatically for you. So the question that you asked falls under this description part here. So here we have an NLP system which computes, I have linear, that means this sentence, and accordingly the parameters of that linear kernel would be relevant.
No, so this would describe the Gaussian process, right? For example, what I meant was in the original PDF that you showed, the airline. So for example, there would be something about I don't know, age of the airline company, that would be increasing for the software thing versus that the small blips would be the daily active driver. So that those features still have to be accommodated in the description.
Yeah, so whatever label you have on the column would directly be used in the system. So if you name it as airline passengers, it would just use airline passenger. So the system doesn't know what is airline passenger. It doesn't know a passenger. What's passenger? It just knows this number and it follows this trend, and that trend has this name. That is what the system is doing. At this point, it's like the human intervention is very less, right? I'm not going to go deep into all the other parts of this system because then it becomes very boring. But then if you're interested, you can read this all on my website or in my dissertation. What I'll quickly do is I'll skip over these because I've already talked about it's just a formula for BIC that you already see here. It's also called penalty. And that's the system ABCD. In aptly named, do it automatically, Bayesian framework. Covariance is a kernel matrix, and that you're trying to discover. That's all I have. Thank you.
It's kind of a product that has been already built.
It's like a research. So it has got grants from Google and Microsoft. So I stumbled across it. And then I did my master's dissertation. I tried to extend this, improve it.
Are you full right now?
Not full. The team that is been working on this is also, I guess, scattered now. They've got jobs in Uber as well as in academia. They've got jobs in TSI. So other companies, they're working with them, Amazon, Uber, and they're also working on this. So it's kind of students who pick this up and they try to make something.
Keep further readings on this.
Yep. One. Happy task.
So, the RStudio system, the accessibility system is always better because in an implicit rating system, every website for say Amazon or Spotify, their implicit rating systems are different. You can't use an implicit rating system for say Flipkart where you're spending too much time on the product or you add a product to the cart. You can't add a product to the cart in a content streaming thing. You're buying a whole service. Their implicit rating system differs for every website. And implicit rating systems are always run by explicit ratings. The RStudio system actually is a great idea because I know for a fact that you actually like this more than this. Just by seeing the textual data, it's difficult to predict whether you actually have added to the cart, but you have added multiple products to the cart. So how would I judge that? Like how do I rank that? So yes, RStudio system is much better.
And the other question is, do you have any so how do you say that So similar users or users in similar geotagging actually behave similarly.
They don't.
So yeah, so I think you specifically mentioned that users in the similar geotagging.
So when I say geotagging, so from a particular IP, for a particular IP, at that amount of time, there are a lot of people who are accessing that website from that area, which is the radius at that particular time. So I want to see what those guys are doing to figure out what to recommend you, because some of those guys will be browsing the same products which you are. And since I don't have any data on you yet, I'm going to recommend those similar products which these guys are browsing, which you are browsing too. Now, when that guy does something else, what am I going to recommend that?
So, I think somewhere we should collectively, we should start capturing the response of, this collaborative filtering model. So, each of the, say for example, retail domain or online domain or those kind of things, we should, so that we get say for example, if we are charging a company, say we'll create a collaborative filtering model or recommendation system, like we are charging 50 lakhs or something. So sometimes we should be able to tell them, this is what the X% of the response you will get from this. So, I mean, not a question, but I think that's a...
Yeah, but like I said, recommendation systems, there's no one solution which fits all. So even for the same company, the core starting problem has different facets. Like I said, you are a returning user, but now suddenly you have started searching for completely different products which are not being searched by you before ever. That's a crucial problem again. So how do I start recommending those products to you? And also content steering, for instance, you can't put the recommendation engine for Netflix onto Spotify. That will not work. Because Spotify is using something completely different. Spotify initially has, I was reading this where actually they have tried to recommend songs based on the waveforms, on a waveform shape. So basically, EDM, for instance, electronic dance music has very uniform waveforms, unlike classical piece or Beethoven or something like that, because that can have a lot of say Bollywood, right? EDM usually has a very periodic, uniform waveform. So if all your songs kind of have a kind of waveform which is using any image processing, it's a very different. You can't really generalize this recommendation system for one solution fits all kind of thing. It probably work for one genre, say commercial, e-commerce maybe, but again, a lot of problems. So recommendation engines is used not just by e-commerce or music, even for Uber or something like that. I want to predict where you want to go next. I'm going to recommend that you use a 50% discount coupon for your next airport ride. That's a different problem again, you can't just generalize this.
I think so, somewhere, say for example, when we talk about all these things to the client, so this sounds like really great, really great, but nowhere we are strongly able to tell them that, okay, so when we apply this in your system, so generally in this domain, 5% is the response, say for example, so whatever you are recommending to them, they will purchase that, or even engaging, they will engage into your system. Even engaging into the system is again response to the client, because he might not buy it, but he still engage with the system, with the client. So somewhere we should be strongly able to tell them that this is what the percentage of response you will be getting.
Yeah, that I think like Manish mentioned, right? Once more the data that comes in, once you have the system in place, and your users start interacting with the system, the more the data, the richer the data set gets.
Yes.
It gets better and better. So after a point of time, it knows exactly what a user wants based on his experience.
So if you want to start building a new recommendation system, so generally for now, example, you are just collecting what all things people are ordering. So what all data points should you start collecting before starting to build the recommendation system?
Are you saying suppose you want to build a new website and
so you have an app from where people are ordering stuff, and now after a few months of starting that app, you want to start building a recommendation system. So you have to start collecting certain data points from now. So what all data points should you start collecting?
Everything the user has done on your app, everything, maximum everything, is clickstream data, what he has browsed, what he has, depends on what your business model is. So, for example, say a music app or say food panda. What are the different kinds of food you have ordered? Are you a non-veg guy or a veg guy? And usually, which place have you ordered? Which are the restaurants you have ordered from? What are the similar restaurants which have got a similar rating from other users who are similar to you? Because I can't just recommend every restaurant to you because there are a lot of restaurants which are non-veg which serve the same kind of food that you do. But a lot of them would have got maybe you would like one particular chicken shawarma from one in this restaurant which has got a 3.6 rating instead of 4.2, which guy makes better shawarma than other guys, but I can't recommend that to you because. So I'm going to take similar ratings. So everything the user has done, starting from transactions, it's basically hosting history, all of it. You start giving more and more weight as the new data comes in, start giving lesser weight as the data gets old after a certain time.
I think I would like to add to that is you should probably collect everything because once you lost that thing, you cannot collect it again. But at the same time, having everything is not enough. You should know why you are having that. So, for example, let's say in your food ordering example, if a particular data point, so whether the hotel is vegetarian or you're vegetarian or non-vegetarian as well, if you don't know where that fits into your hypothesis, then that data point is pointless.
So make sure the more the data, because most of the data, there's going to be a lot of noise in this data as well. Not all of this data is going to be relevant. So at least you want to have a choice of which data is relevant, which is like I said, those normalization things. There are a lot of people who are just do Amazon, they never buy anything. They just want to come and browse, just browse. So those kinds of things, don't want to discount all of that.
I actually have a question for Manish. The Gaussian process that you have showed, for a time series kind of. So I just wanted to know how will you predict the future trend from it? Like, is it same as is it like an alternative for a RMA model or something, or how exactly is it?
Yeah, so
for a Gaussian process, it's very useful for it to do the prediction. As I was saying, that in all machine learning models, what we need is the prediction, right? So once you capture that richness from your data, the predictions are very, very accurate because they can adapt to the noise that you have in your data. They can also adapt to the uncertainties that you have in your data. So the predictions that we get from it are very accurate. So in the PDF that I was trying to show, on the left was the actual data set, but on the right was the modeled one. And that model one was like a replica of the actual. And that, whatever predictions it was showing, was based on the data that you gave. So if your data has lots and lots of values and it's very good, then the predictions are most of it. But if it is very noisy, it can also adapt. It would adapt to the degree to which that you have the noise. If you totally give it something random, you could just learn to random. So again, there's a nice phrase, garbage in is garbage out.
So is there an API support or can we take the support for that?
Because if you're talking about the API support for this system, at the moment there's no API support for this system. Because this was built in a university kind of an environment where it's not thought of commercial aspects. So at this moment it's in a research phase. People are researchers or students are creating more and more enhancements too. So yeah, one day if you are keen, we can think of something and create an API for that. Because one student last year updated this and now it's very accessible. It's like a web page, so you can just put your data in and you get a very quick prediction of or quick decomposition of the components that you see right on your browser screen. You don't have to wait. Earlier, when I started using it, we had to wait for about 10 hours to get something useful because then it works on various servers, it runs MATLAB onto that, does the computes the behavior of it.
What if we don't have the ratings? So can we what the reputation can be used as a
multi-class or multi in case we don't have the ratings.
Don't have the explicit ratings.
Yeah.
Yeah, so that's where the implicit ratings come out. So what I have to understand is the implicit rating system is different for every company. So even though say Prime Video and Netflix, for instance, they both have governance driven, the definition of how they are actually defining the implicit rating system will be very vastly different. So for instance, Netflix, for example, Netflix could be using that if somebody has watched a 2-hour movie over a 1 hour mark, I'm assuming that there is only because of 4. Prime Video could be using something completely different. That only if you just play, I'm assuming that it's given 3. Right, because those implicit ratings will have to be converted into numerical features for your algorithm to work. So those implicit ratings are essential, but how each company is using them to figure which number represents what, that differs a lot. I don't know that. Most of the companies, they don't say how their implicit ratings are being calculated, because when you're giving an explicit rating, say 5 or 4, you know that's a 5 or a 4. But somebody adding a product to the cart but not buying it has more weightage than somebody is browsing through it and coming back with multiple times. Right? So it makes sense for me to give the guy who has added it to his cart but not bought it a 4, but somebody who has come back with say 4 times a 3. So that could differ between Amazon and Flipkart again. That is internal.
So to answer your question, so right now what we are using is like so since ratings are not generally available, so instead of looking at like the rating data, we look at like number of transactions. Now already have. So we use like say for example a drama genre movie. So if you are watching that 3 times and a guy similar to you is also watching 3 times, then it's you guys are similar. So that's
also these days they are using it's not these days, this common practice to actually sift the comments. So comments they are using something called sentiment analysis. So I am able to take the comments that what particular product has and run an NLP on that, break it up to good or bad words based on a data set that is already available on the net, and find out whether this has a positive rating or a negative rating, actually with the percentage of the number of bad words to the number of good words. So that will be a ratio. Right? So if that guy has not given a rating to that, if he is seeing his comments, and it's not about sarcasm, it's very difficult to pick up sarcasm. But generally, if people are honest about what they want to do, you also have some comments where people they want to sell kidneys for headphones. You see these funny comments as well. Not all on those, but comments which are generally well described, it works for those because you can find actually a percentage rating of 50 bad words, 50 negative words compared to 48 positive words. So it's a 53% negative rating. That kind of thing.